going to touch on a little bit of 113 and 114, and I'm doing that before your test because you are going to have to run a regression on your test next week and plug into it to make a prediction, okay? This is by no means all of 113 and 114, but after your test in a couple of weeks, I'll come back to it and show you some more things, okay? What I want you to do, it says the idea of modeling, also called regression, is a major component of the AP pre-calculus curriculum. So this is going to utilize graphing calculator heavily and often include context. So you'll probably see regression on like a free response. In Unit 1, we work with regression models for polynomial functions. Okay, here are the different types of regression you will be able to run in your calculator. Linear, quadratic, cubic, meaning the degree is 3, quartic, which that just is a 4th degree polynomial, and rational functions, which we're not going to really touch on today, but that's what's expected of you by the time you take the AP exam. So to build a regression model in the graphing calculator, you are going to enter the data into lists and spreadsheets. So I'm going to make sure you know how to do that. It's really important that when we do this in just a second, look what I'm pointing to, that you give each column a title. That can just be the letters X and Y. If it's a word problem and you want to put like T for time or C for cost, you want to use those letters, that's fine, but give each column a title. I'll make sure you do that. And then once all the data is entered, we're just going to hit statistics, stat calculations, and then your word problem, more than likely, I hope everyone's hearing this, more than likely your word problem will explicitly say, like, this can be modeled with a cubic regression. And then you're going to know exactly, hey, I got to run a cubic regression. It may say it's modeled by a linear regression, and then you're going to know to choose linear. The harder problems have you make that decision on your own, and we're going to hold off on that for now. So on the test next week, it will say exactly what kind of regression you're supposed to run. Look at this with me really quickly. There are 2 types of linear regression options. There's our friend mx plus b that we're all used to. But we're not going to use that one. We're going to always use a plus bx because if you are currently in an AP Stats class, / if you ever want to take one in the future, this is the form of linear regression we use. It's still the same thing as mx plus b. The slope is b. The slope is still the coefficient of x, just the way you learned it before. And the constant, that's going to be your y-intercept. So highlight or circle, if you have a choice to run a linear regression, use the a plus bx form, which gives you your y-intercept plus your slope times x. And then I'll show you kind of what to do from there. There's just some things I want to make sure you know how to do. So turn the page, and here's a problem. It says the age in weeks and weight in kilograms of 5 randomly selected babies from a particular pediatrician's office are listed in the table above. So we have age, 4, 5, 6, 8, and 12 weeks old, and those babies' weights. Notice it says a linear regression can be used to model these data. If it had said quadratic, then I would run a quadratic regression. It told me linear, so I'm going to run linear. If it said cubic, I would run cubic. Y is the predicted weight of the baby that is X weeks old. So here are little screenshots of what you're going to be doing on your calculator, okay? Write an equation. Our task is to write an equation of the linear model. So we're going to make our calculator give us the A and the B so that we can write y equals a plus bx. So just follow the directions and you're going to be fine. I'm going to say everything out loud, so keep an open ear as you're typing things. Open up a new lists and spreadsheet document. Open up a new list and spreadsheet. It's really important that you give your column a title. You're more than welcome to do T and W, or X and Y. Or you can see on the page there when I did it before, I took the time to type out the word age and weight. It doesn't matter. But the goal here is title each column and then type your data into the spreadsheet. Carefully. When you think you've got it all entered correctly, double check. If you don't enter it in correctly, everything else that you're going to do is a waste of time because it's all going to be wrong. All right, we've got the data entered into our listen spreadsheet. And listen really closely. Right here on this screen, I'm going to run a regression. I'm going to show you in a little while how to run a regression somewhere else. And everything that I'm teaching you is very important, okay? But I'm going to show you how to just run a regression right on this screen in the spreadsheet itself. Hit Menu, Statistics, Stat Calculations. Here are all of your options for all the different kind of regressions there. And it explicitly said linear, and we are always going to choose the A plus BX kind. It takes you to the screen and it says, okay, I'm going to run a regression. What do you want to use for your X's? So there's like a little pull down menu here, and choose whatever you titled your X column. Tab. Use the pull down menu and choose whatever you titled your Y column. If you put weight or W or something like that, choose that. I just use X and Y to keep it easy. I want to point something out. You see how it says save regression to F1? Does everybody say that? That means that when it runs the regression on this screen, it's going to save it to where you can pull up a graph of it later. And I'm going to show you that. But on this screen, all you need to do is choose your X and your Y and then go all the way to OK. And it's going to have all of this stuff that pops out. Look what it tells you. It tells you A. It tells you your y-intercept, 3.43. We'll go out to 3 decimal places, 3.433. It tells you your slope, 0.1925. So now we are ready to write the regression model. I've got it set up for you right here on your notes. If we wrote y equals a plus bx, we would write y equals 3.433 plus 0.193x. There is the regression model. What they'll typically have you do next then is plug into that, make a prediction. If we've got these 5 babies, how old they are and their weight, maybe we could make a prediction about another baby, and that's what Part B is having you do here. Using this linear model from Part A, can we predict the weight of a baby that's 10 weeks old? Now that's pretty easy. What are you going to do? You're just going to plug in 10, right? And is that going to take you very much time? No. But I want to show you something. I want you all to do this. Instead of just plugging in 10 by hand, I want to show you something that's going to be very useful to you in just a second when we run a quartic regression, because you're not going to want to plug into one of those by hand. All right, once you have your regression in your spreadsheet, I want you to hit home. Okay, don't open up a new document. We're just going to kind of continue in our current document. And I want you to choose graphs, the second option there with the little parabola on it. Choose that. And if you've never used it in Inspire, you've got these little tabs at the top. If you wanted to go back to your spreadsheet for a second, you could click on that tab. All your stuff is still there. And then we opened up a graphs document. And I want you to arrow up on this graph. And look, it saved your regression. It saved it. Hit enter. It's got the regression there. So what's really cool is I can just hit Control T and I can go down to 10 and it will essentially be plugging in a 10-week-old baby. It will be plugging in the age and the output. It will tell you the weight. Now again, in this problem, plugging in 10 really wouldn't have been that difficult. But in just a second, you're not going to want to plug into like a really lengthy cubic or quartic regression. If it's really ugly, you're likely to make a mistake. So use this feature. Go to Graphs, Control T, find it. Now, for the sake of having a good set of notes, here's really what it's wanting you to do. It's wanting you to plug in 10. You're going to get the 5.358 kilograms. Go ahead and stick some units on that. And then just make a little note to yourself. Or you could use Control T. Instead of plugging 10 in by hand, you could just use Control T on the graph screen. That way. Now I want to show you something else while we're kind of going on this. I want us to continue in the same document, but I want you to hit Home, and I want you to go to the little purple bar graph one, which is Data and Statistics. I want you to open that one. I'm just going to have another tab there. Eventually, we're going to talk about something called a residual plot. Eventually, you're going to have to do this on this screen. And so what I want to show you is, here's all the baby's data. If you want it to organize it into a scatter plot, I want you to click on the x-axis down there. And I want you to scroll all the way down to what you titled your X column. Click on the y-axis. Scroll down to what you called your y. And it's going to give you a scatter plot of the data. You can also run a regression on this screen. Sometimes you're going to have to do that. So I'm going to just show you that today. I'm just going to show you how. Hit Menu. This time there's not a statistics yet. You have to go to Analyze. And then there's your regression option. So sometimes you have to run a regression on this screen. You don't really know why yet. I'll tell you in the future. But go ahead and run your linear regression, A plus BX, on this screen. It'll plot that line of best fit. It'll tell you the regression equation right here on the screen. And if you want to like grab that and move it around so you can see it better, you can. But now I've shown you how to enter the data, run a regression in the spreadsheet, go to the graph, pull up a table to find a value. I've also now taken you to this screen where you can have the scatter plot and run the regression there. All right, let's go back to this part C. Yes. They really are going to be a graph of best fit. Sometimes if it's not linear and say it's parabolic, it would just be like a function of best fit. All right, part C, the weight of a sixth baby is 5.3. Using the model from part A, what is the age of this baby? You should all be able to handle that. Where do you plug in the 5.3? And what are you solving for? You're solving for X, so you're given the Y value. You're given kilograms. So use your regression model. And solve for X. Do that really quickly. And then I've just got one more that we're going to practice. It's not in the notes anywhere. I found it online. So just let's get this done. Really, here, just make sure you're not rounding until the very end, if you can help it. So subtract. And then divide. And we would predict that if a sixth baby weighs 5.3 kilograms, that they would be about 9.7 weeks old. I'm going to do 9.701 weeks old. And putting your units on there just kind of helps you make sense of what you just found. So I haven't shown you anything earth-shattering. Just how to run a linear regression. You may have even done that in Algebra 2. I don't know. A linear regression. And then use that to plug into. And here's what I want you to do. First of all, does anybody have any questions? Okay. What I want you to do, start all the way over. We're erasing all of that data. Open a brand new list and spreadsheets document on your calculator. I don't have any context for this. I don't know what this is actually about, but what we're going to do is I'm going to show you how to run a quartic regression. So I want you to enter this data into list and spreadsheets. And I'm happy to read them out loud. The X's just go from 0 to 7. Zero, 1, 2, 3, 4, 5, 6, 7. And then the Y's. 26, 14, 9, 9, 6, 7, 13, and 3. And let me get caught up with you guys. This will not work unless you title your columns. Well, I guess technically it would, but it wouldn't work on that scatter plot screen that I showed you where you're labeling your axes. It wouldn't work unless you title your axes. I'm actually curious if it will work if we don't do that for this. Does everybody have the data entered? Double check. You should have ended on the 8th row with 7 and 3. Okay. Run a quartic regression. Let's say you're reading and it tells you this could be modeled by a quartic function. Not quadratic, quartic. Option 8. They're spelled similarly, so be sure you do quartic. If you need help, ask me now. Please don't come up later and say, hey, how did you find that thing in the calculator that was the regression? I was too embarrassed to ask in class. Ask now. Check and see if you got these values once you've run your quartic. Kind of just make sure, scroll up, that these are your values for A, B, C, D. E. You should have an A, a B, a C, a D, and a E. Good box. Oh, I tried, and it was like the guy was going to Okay, here is what you just did. You came up with a function. This is absolutely crazy. You came up with a quartic function. So find somewhere in your notes, find a piece of paper somewhere and write this down, because I just want to show you how you would write this actual function model. Negative 0.058 x to the 4th because that's your A value. B is, so positive, 0.473x cubed. C is positive, so plus 0.656x squared. D is negative, so minus 11.041x. And E is positive, so plus 25.458. That is intense, isn't it? Would you like to plug into that by hand? No. And even if you think, yeah, I can do that, that's no big deal, I'm just typing it in and let the calculator do the work, you're very likely to mistype something. You're very likely to make a mistake. So I want you to actually find f of 5.03. Do not sit there and plug in 5.03 for every single x. As I showed you this earlier, if you will just go to the home screen and open up that graph, the little parabola one there, it already has the function saved for you in F1. Just arrow up, you can see it and hit enter. Arrow up. Now, if you're curious as to what, a quartic, like a fourth degree polynomial, you can drag your screen around, you can zoom out, but really the point here is I want you to know, hit Control T, and it's going to default, it's always going to start at 1 and count by whole numbers. It's going to show you integer values. How again can I have it give me, how can I find an x value of 5.03? How do I change that? Menu, table, edit table settings. Good. Well, heck, if it wants us to find 5.03, let's just start the table at 5.03. From there, it kind of doesn't even matter what you step by, what you count by. I'm just going to put hundredths and then just hit OK. They really stressed this in our training this summer that, you're taking a timed test, so it's important that we teach you the skills to be efficient with your time and not sit there and plug into a quartic equation, especially if it's a bunch of crazy decimals. Instead, I'm showing you how it's already stored in your calculator, and you can just jump right to whatever input value you need in the table and get your output value. So this would be the answer, 9.725, just like that. That's really all I have to show you today. That's, if you want to really quickly, let's go back, let's see if we can pull up a scatter plot of this. So go home and then add data and statistics. Title your axes. And then just practice running a regression on this screen. You don't really know why you're doing that yet. Abby does. Abby Holder. Quartic. Because I'll show you later why we need this screen and why we need to run the regression to look at something called a residual plot. But we'll do that later. Yes? Oh, menu, analyze. And then from there, you've got the regression option. Okay, that's it, you guys.